Yeah, well, welcome back to the last segments on variation, and this is the fourth kinds of variation, and that is a partial variation. We've already discussed in the previous video direct variations, inverse variation, joint variation, and this is the last part on variation, which is what? Partial variation. Okay, and what is partial variation? We can only explain this that sum of two or more parts. Okay, sum of two or more parts. Okay, and then the next thing to note is that the number of constants, okay, the number of depends on the what, on the number of variables involved. Okay, the number of constants depend on the variable involved. That's that. And how do we get those constants? Okay, those constants can be gotten using simultaneous equations. Okay, so the next thing I want to show us now, I want to show to us the form of those questions and how we can turn those form of those questions to mathematical expression. And after that, begin to look at questions and solve them. Okay, let's see. And let's look at interpretations of these two forms. The first one is y varies partly directly as s, and partly directly as the square of s. Okay, so what this means is that y, okay, it varies partly directly. Y varies, y is equal to, okay, varies partly directly. Okay, when you have partly directly, there must be what? There must be a constant, okay, before the variable given to you. Partly directly as what? As x. Okay, and have a plus, and partly directly as what? As the square of what? Of x. So anytime you have partly directly, there must be what? There must be a constant. Okay, another constant before the given variable. That's what? Square of what? Square of x. Okay, so that's the first form of question that can be given to you under partial variation. Then the second part, y is partly constant. Y, okay, is, that's equal to partly constant, nothing. It's just partly constant. That means y is what? Any constant you like. You can use b if you like. So there's no variable mentioned here. It's just partly constant. And that's plus, partly varies inversely. In this case now, this is the inverse. So partly varies inversely. So in that case now, a constant must be introduced. That's what? That will be different from the first constant we have used here. Then you can go for c over what? Over. Since it's an inversely as well, at the square of what? At the square of t. Okay, so these are the two forms, okay, that you can have under partial variation. Yeah, question 1, v varies partly as q and partly as q squared. When v is 34, q is 2. And when v is 190, q is 5. Find v when q is 10. Okay, so if you look at this question, without wasting time, you just go straight and write the mathematical expression. V is what? V varies partly as what? As q. Okay, this varies partly. Okay, it could also be varies partly directly. Okay, so it's going to be what? You're going to introduce a constant, okay, before what? Before the given variable. Okay, you can use any letter for your constant, any alphabet for your constants. And that's plus, partly as what? As q squared. Another constant must be introduced. Another what? Partly as q squared. Another what? Another constant must be introduced. So I can use d q what? Q squared. And if you observe now, you can see your variable is what? It's the same. It's only the constants that what? That are different. So what we have now is begin to substitute now. When v is 34, q is what? Q is 2. That will be 2 times b, 2b plus what? This is 2 squared, that's 4d. equation 1. Then we go to the next one, and when v is 190, q is what? Q is 5. So I'm going to have 5 times b, 5b plus 5 squared, that's 25 what? 25d equal to what? 2. So, and I've said at the beginning, at the introduction, that the only way you can solve a partial fraction is what? Is to use simultaneous equation, because in equation we involve 2 equations, okay? Then you solve it simultaneously, okay? So this is what we have now. So how do you solve this? So the choice is now yours now. So what I want to do now, I want to assume that we don't know simultaneous equation. I want to assume that. So what we do is that I want to use an elimination method. Okay, and I want to make the coefficient of b in the 2 equations to be the same thing. So I'm going to multiply equation 1 times 5, and this one times what? Times 2. Okay, in the first case, I want to eliminate b and get my what? And get my d. So I have to use the coefficient of b of the second equation to multiply the first equation, coefficient of b in the first equation to multiply the second equation. That will be 5 times 34. So that will be 170 equal to 5 times 2, that's a 10b, 5 times 4, that's a 20d. So equation 3. Then the second one times 2, that will be 380 equal to 5 times 2, that's a 10b, 25 times 2, that's a 50d, equation 4. And you can now see now the b coefficients are now the same. Okay, then I can now say, okay, I can say now equation 4 minus 3, or 3 minus 4. So equation 3 minus what? Minus 3. I mean equation 4 minus 3. So 380 minus 170. 380 minus 170, that will give me 210. 10b minus 10b, that cancel. Then 50 minus 20, that's 30 what? 30d. So in this case now, d is equal to what? 210 over what? Over 30. And that's what? That's 7. So I've gotten d now. Okay, but d is not the only constant we have there. So the next thing to do now is to go to any of the equations, either equation 1, 2, 3, or 4, and plug in the value of d. Okay, so that you can get the other constants. Okay, let's go for equation 1. Equation 1 is this. 34 equal to what? 2b plus 4d. Okay, substitute d equal to 7 into the equation 1. So that will be 34 equal to 2b plus 4 times what? 4 times 7. So I'm now having now 34 equal to 2b plus what? 28. Okay, then you can move this one, collect like times. 34 minus 28 equal to what? 2b. Okay, and this will be equal to what? This will be equal to 6 equal to 2b. So b is what? B is 3. So b is 3. That's that on these question. Then the next thing to now do now, the question says we should find b when q is what? Is 10. Go back to your equation. V equal to our b is what? We have the value for b. B is what? B is 3. That will be 3q plus d is what? 7q squared. So that's the relationship that connects the formula together. Then we can now go back here, find v when q is what? 10. So v is equal to what? 3 times 10 plus 7 times what? 10 squared. Okay? So we're going to have 30 plus 10 squared is 100 times 7, that's 700. And that's what? That's 730. Okay? So that's that on this question on partial variation. Okay? So let's go to the second question.